All right, welcome to the second part of section 10.1. This video is going to be much shorter than the first one you watched. It's going to be really straight to the point, down and dirty and easy. We're going to be doing a lot of stuff that you already know how to do, like distribution and combining like terms. Okay, I think this is going to be a breeze for most of us. What we're going to do in this lesson is to write a quadratic function like we talked about in the first video in standard form. And if you remember, this is the one that had the ax squared plus bx plus c. We're going to take the intercept form and the vertex form that we talked about in the first video and transform it into standard form. And if we were to take a look at standard form again, notice how there aren't any parentheses. Everything is very simple, straightforward, to the point, like it's completely simplified. So when we look at intercept form and vertex form, we actually have parentheses going on. So if we want to convert it to standard form, that means we want to get rid of the parentheses. Okay, we don't want any parentheses. And we know that in order to get rid of parentheses, we're going to have to do some distribution. So this lesson is going to be really easy. We're just going to be doing a lot of distribution and a lot of combining like terms. So let's start off with intercept form. We have this quadratic equation right here. It has two intercepts, -4 and +9. Remember, you always look for those opposite ones. And we want to convert this intercept form equation into standard form. So to get rid of the parentheses, we want to try to distribute. So first thing I notice is maybe let's distribute in the negative sign. So that would turn it into a -x and then a -4. And the negative sign was only in front of the first parenthesis group. It's only touching the first parenthesis. We do not have to distribute it into the second one. Okay, we only need to bring it into the first. But notice how we still have parentheses. Okay, if we want to get standard form, this equation to look like ax squared plus bx plus c, we don't want any parentheses. So we're going to do a little bit more distribution. Or some of you might be fans of the box method. You can do a little box method on this one where you put, I think, -x and -4 up top, and then maybe x and a -9 over here. Okay, you guys are more than welcome to use the box method if you'd like to. I, on the other hand, prefer distribution. It's just a personal choice. But some of you guys might like the box method. So I'm going to do distribution. Let's first bring in the -x. So -x times x would give us a -x squared. -x times -9 would give us a positive 9x. So there's our first distribution. Now we got to bring in the second distribution. We need to bring in the -4. So we have -4 times x, which is -4x, and then -4 times -9 would give us a positive 36. So now we're really starting to look like this ax squared plus bx plus c. Notice how all the parentheses gone. We have some type of squared term. We have a few lonely x's. Maybe we can combine these together. Those are like terms, and we have a number all by itself. So if I combine some like terms, the x's in the middle, we have 9x minus 4x. That would give us a positive 5x. And there's standard form. Notice how we have an ax squared, a bx, and a c. In this case, a would be -1, b would be 5, and c would be 36. So these are both actually the same equation. Okay, they just look different. This standard form equation could be written as this intercept form, and this intercept form can be written as the standard form. Okay, they are exactly the same equation. If you were to graph them, they'd give you the same exact graph. It's just that they look different. Okay, they're in a different type of quadratic form. So that's intercept. Really easy, just a bunch of distribution and combining like terms. When we talk about vertex form, though, we need to be really careful on how we actually go through the distribution process. A lot of us will want to distribute in the -2 automatically. Okay, but we actually cannot do that because notice how this first parenthesis group right here is all by itself. Okay, we can bring in that little -1. But this group right here is being squared. And if we can remember what that squared is telling us, it means that we have two of these groups. So I can write x plus 3 twice. Okay, so let's take a little side note. Okay, right here, maybe you want to say do not distribute, if my pen will work, distribute the 2. Okay, you cannot do that first. Okay, the first thing you have to do is rewrite it, and that's why I put this little note right here, rewrite if necessary. And this is a case where it was necessary. We have this little power of 2 telling us we have 2 of these groups. Now that we rewrote it, okay, now it's okay to distribute in the negative 2. Because notice how what we have here, at least part of it, looks like the intercept form we had over here. Okay, both of these groups, both of these parenthesis sets are by themselves. So we can distribute in the negative 2. I meant for it to look like this, not to go into the other one. So we can have negative 2x, and then we have negative 2 and 3 would give us a negative 6. All right, so just like the negative sign over here, we only distribute it into the first parenthesis group. That's what we're doing with the negative 2. The second one can stay exactly the same. All right, so we have 2 parenthesis groups, just like we did over here. Let's distribute everything in nice and neatly. Again, you can use the box method in this case if you want to. Okay, whatever floats your boat. Let's bring in the negative 2. So we have negative 2x squared. If I bring it in again, I get negative 6x. If we bring in the negative 6, we get a negative 6x. Bring it in again, we get negative 18. And last but not least, we have, oh, this should be minus 4. We should bring down the minus 4. All right, so now, again, it's starting to look like this standard form. We have some x squared term, we have a few x terms, we have a few number terms, just like what we have up here, but again, standard form is when everything is simplified. So we want to combine as many like terms as we can. I think the negative 2x squared is the only x squared term. Yep. So let's combine the x's. Negative 6 and negative 6 can give us negative 12x. And then the numbers, negative 4 or negative 18 and negative 4 can give us negative 22. All right. So there's our standard form. We converted vertex. Okay, that's what we started with. We converted vertex into standard. And just in case you want to label them, we have negative 2 as an A, negative 12 as a B, and negative 22 as a C. All right, so a bunch of distribution, a bunch of combining like terms, okay, things I think we're really good with. All right, so what I want you to do is pause and try these 2 on your own. Maybe we can label these so we know which one we're dealing with. Letter B is vertex form. Remember, this is the one where we can actually find the vertex, where we know the H and the K. And then the other one happens to be intercept form, where we know where our 2 x-intercepts are. We would have one at a positive 1 and another x-intercept at negative 3. All right, so pause, try these. I want you to make them look like standard form. That was the ax squared plus bx plus c. All right, so pause, go ahead, give them a shot. All right, so let's check out and see how it did. For letter B, since it was in vertex form, we really had to be careful with this power of 2. Okay, remember that's telling us we have 2 identical sets of this x minus 1 in this case. So we can rewrite it as x minus 1 twice. Next thing we can do is distribute in the 3 just to the first group. So that's what we have here. And now that we did that, we can actually do a little bit more distribution. We can bring the 3x to the x to get the 3x squared. 3x to the negative 1, we got negative 3x, and then next we can bring in the negative 3 to the x, so we get negative 3x, and then the negative 3 to the negative 1, which would give us the positive 3. And just notice how the plus 8 kind of keeps carrying itself down the entire way until we start to combine some like terms. So the 3x squared, nothing else matches that, so that stays. We can combine the x's together to give us the negative 6x. And we can combine the numbers together to give us that positive 11. So for letter B, we transformed a vertex form quadratic equation into a standard form quadratic equation where we can label the A, B, and C values. So hopefully we did really well in that one. If we check out letter D, this time we're starting in intercept form, and we can distribute in the 2 just to the first group, so we get 2x minus 2, and we can do a little bit more distribution. We still got to get rid of those parentheses. We can bring in the 2x to the x to give us 2x squared, the 2x to the 3 to give us the 6x. Then we can bring in the negative 2 to the x, we get negative 2x, and the negative 2 to the 3, which would give us the negative 6. Lastly, just combining some like terms, the x's in the middle can give us a 4x. So this time we converted an intercept form into standard form, and you can label the A, B's, and C's when you look at that. So hopefully we did really well. Okay, again, I think this is going to be kind of easy for us, so we're going to keep this video short, sweet, and to the point, and we're going to do a lot more of these just for some practice next class. All right, so I'll see you guys later.